Factors are two numbers we multiply together to get another number. In this example, I show that 2 and 6 are factors because we multiply them to get 12. Oftentimes we want to go ahead and make a factor tree to get the prime factorization of a number. For example, let's look at 12. 12 we can factor down using two branches, that's why we call it a tree there, to 2 times 6. But 6 we can also further factor. We want to factor as much as possible. 6 we get 2 times 3. And each of those we can't factor anymore. So we would say the prime factorization of 12 is the n branches of our tree. 2 times 2 times 3 would be 12. Let's look at another example. Let's say we have the number 24, and we want to find the prime factorization of 24. Let's start with 2 times 12. It doesn't really matter what you start with as long as it multiplies to 24. You can have other starts as well. 12 you can do 2 times 6. 6 you can do 2 times 3. And we're done. 2 and 3 are all prime numbers. We can't factor them anymore. So we could use the n branches, 2, 2, 2, and 3. And the prime factorization of 24 would be each one of those. 2 times 2 times 2 times 3. Let's look at a more difficult one. Let's say we have a bigger number like 315. Well, I first noticed that 3 can go into 3 and 3 can go into 15, so I can do 3 into there. 3 into 3 would be 1. 3 into 15 would be 5. Then I look at this number. This number ends in a 5. Well, the other one ends in a 5 too, but this one ends in a 5. I can go ahead and divide it by 5. 5 into 10 would be 2. 5 into 5 would be 1. And 21 would be 3 times 7. And that would be the end. 3 and 7, I can't factor those anymore if I tried, right? Like 7 would just be 7 and 1. And we don't want to multiply by 1. That's already prime there. So we look at our n factorizations. 3, 5, 3, and 7. We'd say that the prime factorization of 315 is 3 times 5 times 3 times 7.